Hello everyone, welcome back to Pharmaceutical Concepts. X-ray diffraction techniques are a very useful characterization tools to study non-destructively the crystallographic structures, chemical composition and physical properties of materials and thin films. Diffraction pattern provides the atomic structures of molecules such as powders, small molecules or larger ordered molecules like protein crystals also. Let us see more details about it.
So firstly, what is XRD? XRD is basically a technique, an analytical technique that is used to measure crystalline compounds only, and it can provide quantitative as well as qualitative analysis of a compound. So it can be used to quantify as well as qualitate the particular compound. So its basic principle is you just impart an X-rays, that is, there is a source of a X-ray. We will discuss the different sources available like radioisotopes. And so firstly, this X-rays are bombarded or they are exposed to a lead screen, and then through this lead screen it comes in contact with your compound, whatever it can be any crystalline substance over here. So here you can see the X-rays from the source are being imparted towards the sample holder, and from that sample there will be various spots that these are called as diffracted X-ray spots on the photographic plate. So how is it going? Firstly, there is X-rays that are generated through the lead screen. They are imparted or they are exposed to the sample holder, and through that there are various diffracted X-ray spots seen on the photographic plate. So this measurement can be done to understand the composition at an atomic level. This word is very important, to understand the composition at an atomic level. So XRD can help you to find out or of different structural makeup, structural elucidation, and also the size of the crystalline structures.
Here if you see the line and the small circles, this is how the crystals are built up of regular arrangements of atoms in three dimensions. These arrangements can be represented by repeat unit or motif, which is called as a unit cell. Since the wavelength of X-rays is similar to the distance between crystal layers, incident X-rays will be diffracted, interacting with the certain crystalline layers and diffraction patterns containing important structural information. Now, this structural information is about the crystal which is obtained by XRD. The diffraction pattern is considered as the fingerprint of that particular crystal because each crystal structure produces unique diffraction pattern and every phase in a mixture produces its diffraction pattern independently.
Next up we have is Bragg's diffraction law. Now, what does this Bragg's diffraction law states? This formula is extremely important. N lambda is equal to 2d sine theta. So here, if we see, there is an incident ray and there is a refracted ray or the diffracted ray, to be more precise in case of XRD. So here incident ray and diffracted ray are present. Here there are two incident rays. Here you can see first one over here there is an angle made, and then that ray it is getting striked upon a particular plane and it is getting diffracted over here. This angle is represented by theta. So now if we see that on the second ray, about the second incident ray is again getting striked upon the second atomic plane, and after getting striked upon the second atomic plane, it is then again getting diffracted. Again there is an angle made. So these angles are very useful for, and are actually the main basis of the Bragg's diffraction law. Path difference. N can be either 1, N can be 2, N can be 3, and so on and so forth. So here you can see the path difference. So the path difference is over here delta is represented by delta. Delta is equal to CB plus BD. So the length of CB is and the length of BD, their addition will give you the path difference. So here the path difference will be d sine theta, which is the angle made, and d sine theta for BD. So it will be 2d sine theta. Now path difference is represented by n lambda as well. So here you can see n lambda is equal to 2d sine theta. They have just equated the two equations. This is equation. So these two equations after getting equated, they give the formula of n lambda 2d sine theta.